So to reduce or simplify fractions, we can use prime factorization and a light. There you go. So to reduce or simplify, and you can do this on the paper that you have, we can use prime factorization, okay? So for 30 and then 36. Someone raise your hand and give me two factors of 30. Diego. 3 and 10. All right. What do I do next, Chris? What should I do next?
Do the 10.
Okay. With the 10, what do you want me to do to it?
Do the numbers of 10.
The numbers of 10, which will be prime factorization. Go ahead and say prime factorization.
Prime factorization.
All right. Let's break 10 down, because prime factorization is just breaking it into its prime factors. Tia, what would you like? 5 times 2. Now we're missing something. Jayla. We forgot to circle 3.
Miss Morgan, if you're in there, please call the front desk.
And also, what else is a prime number?
2.
2 and 5. Those are all prime numbers. So the prime factorization for 30 is 2 times 3 times 5. Okay? Let's try 36. Someone give me factors. Chelsea. 6 and 6. All right. Yadiel, can you give me factors of 6? 3 times 2. And because this is 6, we'll go ahead and do that one as well. 3 times 2. And what do we do with these numbers? Circle and stop. Circle and stop. Circle and stop. Circle and stop. We circle and stop because they're prime numbers. And so here, I'm going to put 2 and then check each one that I write down just to make sure that I have all of my numbers written down. So 1, 2, 3, 4, 1, 2, 3, 4, and then there's 3 here, okay? Now when you're reducing or simplifying, it means the same thing. To reduce or to simplify a fraction is going to be the same thing. You have to make sure that you divide out the numbers properly. So everything I have at the top, I have to be able to divide out the top and the bottom, okay? Anything I want to divide out, I have to have it at the top and the bottom. So what can I divide out of the top and the bottom? Let me see. Yesenia, what is the same? What number do you see that the same at the top and at the bottom?
3.
3, okay? So I'm going to divide out a 3 here and a 3 here, all right? Adrian, what number do you see that's the same at the top and the bottom? 2. So I'm going to divide out a 2 here and a 2 here. All right? Are there any other numbers that are the same? Yes or no? No. So let's go ahead and do what it tells us, which is multiply. So 5 is alone at the top, so we'll put 5 here. And then we have 2 times 3, and that's going to be 6. So 30 over 36 reduced or simplified equals 5, 6. Okay? That's how to do it using prime factorization. So this is using prime factorization. And the reason why we use prime factorization many times is because you guys have not learned your multiplication facts. And so sometimes it's difficult for you to remember what the multiples are. Okay? But earlier, Jayla said that she recognized that 30 and 36 were multiples of 6. Okay? So I'm going to take 30 over 36. And if they're multiples of 6, if I want, multiplying makes numbers what? Bigger. And so what if I want to make something simplified or reduced, what would I do? Divide, which is the opposite of multiplication. So multiplication makes things bigger, and if I want to make it smaller, I want to do what? Divide. I'm going to put a division sign here. Now, this is not the way that I normally teach it, but I know a parent taught their student this, and the student was asking me a question about it. And so this is confirming your parents, okay? All right, this is just confirming. So I'm dividing this, and you said it was a multiple of what, Jayla? 6. So I can divide the top by 6 and the bottom by 6. So now, 30 divided by 6 is what? 36 divided by 6 is what? 6. It's the same answer that we got here. This is the way that your parents do it because they know their multiples. This is not the way that I show you in class because we don't know our multiples and we want to make sure that you understand exactly what you're taking out. And if you look at the top, what we did, what's 2 times 3? 6. What's 2 times 3?
6.
So we did the same thing, we just showed it a little bit differently, okay? So the expectation is for you to do this. When you're using prime factorization, that's how I expect you to reduce or simplify your fractions, whereas your parents probably know this one, okay? I'm not expecting you to do this. I am expecting to see this. I want to see you're breaking down your numbers and then using prime factorization to reduce your fractions, okay? You'll get the same answers that your parents get, so I'm just going to label this parents' way because this is probably what they know. Okay? All right. Jadacia, can I help you?
What, like, so we only X out one of the numbers, so we can't X out 2 2s or 3 3s?
Oh, I like that question. Jadacia said, well, we can only X out one of the numbers. I can't X out both of the 2s. You can only divide one at the top and one at the bottom at a time. So if I'm going to take a 2 out here, I take a 2 out here. There's no other 2 that matches this. It's like twins. You want to take the 2 out together. Okay, once you take it out, you can't take it out again because it's gone. You can only take out 1 2 because otherwise you take out 2 here and then 4 here. Okay? So you're dividing out 2 here and you're dividing out 2 here. Stephanie.
If we know our multiples, could we do it the parents' way, or you want us to do it the other way?
I know some of you know your multiples, but I'd prefer that you do it the reduced or simplified way. I'm not actually showing you the parents' way. I'm confirming what they say because your parents know it this way. This is the way they want to show you if they're helping you with homework. But I'd prefer that you show me this way, using prime factorization. And that may change when you go to middle school, but in 5th grade, we're going to use this strategy. Yes, Jadacia?
What if, like, the bottom and the top don't have the same numbers?
Then you can't reduce it. It is at its simplest form. If you can't reduce it, you can't reduce it. I'll show you one. Let's do 21 over 45. All right? 21 we can break down to what? Oh, that's not, wait, will that work? Nope, that won't work. Because there's something in here. Let's do that. 3 times 7. And then 45 is 9 times 5. 9 is 3 times 3, and then times 5. So I could reduce that. Let's find another one. Let's do 21 over 40. Thank you for paying attention. Now, 21, as we said, was 3 times 7. And 40 breaks down to 5 times 8. 5 is a prime number. And then 8 is 4 times 2. That 2 is a prime number. And then here is 2 times 2 times 2. So 1, 2, 3, 4, 1, 2, 3, 4. So are there any 3s at the bottom?
No.
Are there any 7s at the bottom?
No.
So this fraction is at its simplest form. We cannot simplify this fraction any longer. Do you understand that? This one we could divide out a 3 here and divide out a 3 here. It would be 7 over 3 times 5 is what? 15. Good job. Now here, there's nothing to divide out because there's no numbers that are the same at the top and at the bottom. Are there any questions? Okay. So this is how we would use prime factorization to simplify a fraction. Prime factorization to simplify a fraction. This is a fraction that we cannot simplify because there are no prime numbers in common. Okay? This is the way that I'd like you to use it in class, the prime factorization way of simplifying your fractions. However, this is also accurate. This is what your parents know, but your parents do it this way because they learn differently and because they know their multiplication facts. Okay? So which one are we using in class?
Prime factorization.
prime factorization. All right? Thank you.